Hello everyone. Today we'll study the program to separate positive and negative numbers in 8051 microcontroller. Okay. First we'll see how the algorithm or how the logic of the program is. What we need to do, first step is, first we need to set the source pointer to the start of the number list. Okay. Wherever we have stored the data, we need to identify the address of that data. Okay. Next we need to set the destination pointers. We need two destination pointers. One is to store the positive number and the second one is to store the negative number. Okay. Now in the second step, what we need to do, whatever the source data is there from the source address location, we need to take the first number from that location. And in the first number, we need to check the MSB bit of that data. If the MSB bit is 1, that indicates the number is negative. If the MSB bit is 0, that indicates a number is positive. Okay. And in the third step, we need to store that particular number. Whether if it is a negative number, we need to store that in the negative address location. If it is a positive number, we need to store it in the positive number address location. In the fourth step, we need to repeat this process from 2 to 4 until the number of count becomes 0. Okay, that's the end of the program. This is how the logic or algorithm is. Now let's see how the program is. Okay, now as I told, first we need to initialize the address of the actual data. Here we have taken the address in move dptr comma hash 9000h. 9000h is the external memory location. Okay, I have stored my data in the external memory location 9000h. Okay, now I need to initialize two more address location. One is to store the positive numbers, another one is to store the negative numbers. Here I have taken R0 comma hash 20h to store the positive numbers. 20h is my address location, internal address location to store the positive numbers. Similarly, 10h is my internal address location to store the negative numbers. And move R2 comma hash 05. 05 indicates the number of datas I need to check. Okay, here I am checking 5 datas. Fine. Now this is the first step, initialization. What is the second step? We need to take the first data from the source location. Here move x a comma at dptr indicates we are taking the first data from the source location. Once we are taken the data, I am just copying the data to B, one more register B. Now what is the next step we are doing? We are rotating the content of that accumulator to left through carry. Okay, what does that indicates? Suppose if you can see from this diagram, this is my 8-bit data from 0 to 7. What does RLC instruction does is, whatever the content is there in the accumulator register, it will shift that data one position to the left through carry. That means the 0th bit will come to first position, first bit will come to second position, second bit will come to third position, third bit will come to fourth position, fourth bit will come to fifth, fifth bit will come to sixth, sixth bit will come to seventh, and seventh bit will come to carry bit, which is in the PSW register, and whatever the data is there in the carry, it will come back to LSB bit. This is what the procedure of RLC register. Okay, so why we are doing this RLC register? Because we need to check the MSB bit of the number. If the MSB bit is 1, that indicates the number is negative. If the MSB bit is 0, that indicates the number is positive. Okay, so in order to check the MSB bit, I am taking that MSB bit into carry flag, because carry flag is a bit addressable. We can check a single position. Okay, so what it basically does, RLC, the MSB bit is moved to carry bit. Okay, carry flag. Next I am checking the carry flag, whether it is a carry flag is 1 or 0. JC indicates jump on carry. If the carry bit is 1, it will go to this label. What it does in this label, it will store that whatever the data is there into the negative destination location. Whatever the address we have taken to store the negative address. Here what we have initialized? We have initialized 10h as a negative data. Okay, negative address location. So it will move to that particular position and it will increment the address in order to store the next data. Suppose if the carry bit is 0, what it will do? It will store that data into positive destination location. Okay, here in our program we have initialized it as 20h. 20h is the destination location to store the positive numbers. Once it is stored into positive location, it will increment the address of the positive location so that it can store the further data. Okay. After this, what happens, even we need to increment the source location also in order to fetch the new data. So that's why we are taken increment dptr. Okay, next we need to, out of 5 data we have already transferred 1 data, so that remaining how many data we need to transfer? Still 4 more data are there to transfer. So that's why we need to use djnz. djnz indicates decrement jump on no zero. It will decrement the content of R2 by 1, and if the R2 content is not equal to 0, it will go back to the label. Okay, this is the fourth step, as we explained in our algorithm. This is the fourth step. Until the data becomes 0, number of data count becomes 0, the process will go on repeat. Okay, now let's see how our program works in the software. Okay, this is the program. Now I'll execute this one. First we'll check for any 0 error. We'll go to debug session. Here we'll give our data in our location is, source location is 9000H. So I am giving data in that 9000H location, whatever the data you want to give. I am giving F0 82 26 32 95. Okay, this is my 5 data I have given, F0, 82, 26, 32 and 95. By looking into this, we can easily identify F0 is a negative number, 82 is a negative number and 95 is a negative number. That means the memory location 10 from 10, 11 and 12, it has to store F0, 82 and 95. And in 20th, it has 20th location and 21st location, it has to store 26 and 32. Now let's see. Initially 20th location and 21 location is all 0. Similarly 10, 11, 12 is also 0. Now if I execute this program, you can see here, we have initialized 10H memory location to store the negative numbers. You can see it is separated, F0, 82 and 95. Only these negative numbers are stored in from the 10H location. Similarly, 20H memory location we have initialized to store the positive numbers. 26 and 32 are the positive numbers. It is stored in 20H location. That's the end of the program. Thank you.